are together connected, means positive terminals are connected to the one side of this, and second negative terminals of the side connected to the second terminal. So consider two cells are connected in parallel. Here positive terminals of all the cells are connected together and the negative terminals of all the cells are connected together. So the current is divides among the branches, that is I1 and I2 as shown in figure. So now here we know that I1 and I2. So current divided into two parts. So consider points B1 and B2 having potentials VB1 and VB2 respectively. For the first cell, the potential difference across its terminals is, so now we know that here in series combination voltage are increases, but here current is divided, potential becomes same. So here V is equal to, so let us see potential. So V is equal to VB1 minus VB2 is equal to epsilon 1 minus I1 R1. Here we write epsilon 1 means last equation. We know that electromotive force means epsilon 1 minus I1 R1. I means current, R means internal resistance of a cell. It's equation number 1. So I1 is equal to, rearrange this equation. I1 is equal to epsilon 1 minus V upon R1. This is the equation number 2. So point B1 and B2 are connected exactly similar to the second cell. So V is equal to VB1 minus VB2 is equal to epsilon 2 minus I2 R2. So we first find out for B1 and then now for B2 is connected exactly similar. So we get same equation. So therefore I2 is equal to epsilon 2 minus V upon R2. This is the equation number 3. So now I is equal to I1 plus I2 means current get together. So I is equal to epsilon 1 upon R1 minus V upon R1. Similarly here plus epsilon 2 upon R2 minus V upon R2. Okay. So from equation number 2 and 3 we get equation number 4. So therefore epsilon 1 R1 plus epsilon 2 R2 minus V common कर ले, 1 upon R1 plus 1 upon R2. So solving this we get this. So V in bracket of 1 upon R1 plus 1 upon R2 is equal to epsilon 1 R1 plus epsilon 2 R2 minus I. Okay. So now cross multiplication of this equation we get V is equal to R1 plus R2 upon R1 R2 epsilon 1 into R2 epsilon 2 into R1 upon R1 R2 minus I. So V is equal to epsilon 1 R2 plus epsilon 2 R1 upon R1 plus R2 in this equation minus I into this. This is the multiplication. Now reciprocal of this equation. So R1 R2 is numerator and R1 plus R2 is denominator. So R1 R2 upon R1 plus R2. So if single cell are connected between points B1 and B2 with the EMF, E equivalent and internal resistance R equivalent is. Okay? So epsilon means electromotive force, R means internal resistance. So epsilon equivalent is equal to epsilon 1 R2 plus epsilon R1 upon R1 plus R2, and R equivalent is equal to R1 R2 upon R1 plus R2. So that is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 from this equation. So epsilon equivalent upon R equivalent is equal to epsilon 1 R1 plus epsilon 2 R2. So the equation number 6. So from n number of cells in parallel, so 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 up to 1 upon Rn, and epsilon equivalent upon R equivalent is equal to epsilon 1 R1 plus epsilon 2 R2 plus up to epsilon n Rn. So equation 7 and 8 we get. So this equation gives the cells in a parallel combination. So now advantages of cells in parallel. So for cells connected in parallel in a circuit, the circuit will not break open even if a cell gets damaged or open. So break होत नाही सर्किट, त्यासाठी आपण हा parallel combination चा advantage. And disadvantage of cell in parallel: the voltage developed by the cells in parallel connection cannot be increased by increasing number of cells present in circuit. कारण आपण बघितलं करंट डिवाइड होतोय आणि व्होल्टेज सेम राहतोय, त्यामुळे आपण जरी सेल्सचं कॉम्बिनेशन इन्क्रीज केलं तरी व्होल्टेज इन्क्रीज होणार नाही. सो पॅरलल कॉम्बिनेशनमध्ये फक्त करंट डिवाइड होतो, व्होल्टेज कॉन्स्टंट राहतो. ओके. सो नाउ लास्ट पॉइंट इन दिस चॅप्टर इज टाइप्स ऑफ सेल्स. फर्स्ट वन इज प्रायमरी सेल्स and second one is secondary cells. So in primary cells it can be charged again, but in secondary cells it is rechargeable and can be reused. The primary cell cannot be recharged. Okay, and second one is they are low cost and can be used easily. But in secondary cells it is suitable for heavy loads. Okay, so for example, primary cells are dry cells and alkaline cells. We know that the dry cell, our regular cells are called dry cells. Okay, and now secondary cells is, for example, lead acid cell, fuel cell and solar cells. We know that the solar cell solar energy is converted into electrical energy, and fuel cell mostly used in a electricity motorcycle. Okay, so this is the different types of cells. So primary divided into primary cells and secondary cells. Okay, इथे आपलं चॅप्टर कंप्लीट झालेलं आहे आणि मोस्टली पॉइंट्स तरी तुम्हाला समजलेले आहेत. यातले 2 न्यूमेरिकल्स आपले कंप्लीट झालेले आहेत.